In this video, I'll be showing you how to make a snake game for the Commodore 64 in BASIC. So turn on your Commodores and let's get started. All right, we're going to get started by typing in 10 prints CHR 147. This is going to clear the screen. We can run it and it's going to clear the screen. Next, what we need to do is we need to create an array for our snake. Our snake is going to continue to grow and grow and grow, and we need to make sure that we set aside some information for that so that we can add that to our array. So to do that, we'll do 20 and then dim. And then for our X, we'll have 100. And then comma for our Y, we'll have another 100. You can actually make these 200, 300. Actually, we'll do 200 and then we'll hit enter. And next, what we want to do is we want to create some variables for our screen memory, but also our color memory. So we can do this by doing 30 SM is equal to 1024. This address is where screen memory starts, and then we'll do a colon, and then we'll do our color memory for CM, and then we're going to type in 55296. This is where our screen memory is going to start and where our color memory is going to start. Next, we're going to create a few more variables. We'll do 40, and then we'll do SN for snake, and this is going to be our snake character icon, what we're going to use for our snake. So we'll make it 81. We'll do a colon. We're going to use a character for space. After we're going to be erasing our tail. And in order to do that, we need to replace it with a blank image. And so we'll just do SP and then we'll do 32. This is a blank image character for Petsky. And then the last one we'll do FD for food. And then we will pass in 42. We'll see what these look like later, but it's easy to set them up now. And then we'll do two more. We're going to do colors for our character. We're going to change our color of our character to white, and then we're going to change the color of our food to yellow. So we can do SC for snake color is going to be equal to 1, and then we'll do FC for food color, and this is going to be yellow, which is going to be 7. Perfect. Now what we can do is we can set up our snake. So we can do that by doing 60 and then X. And then for the first one of our array, so number 1, we're going to just put 10. This is where it's going to show up on our X of our screen. And then we will do colon, and then we'll do the same for our Y. Y1 equals 10. And what this does is we're going to set our X and our Y to 10, 10, and this will allow us to place our snake later in the game. We need 3 of them to start, so we'll just do the rest. This is going to be equal to 9, and our Y2 is going to be equal to 10. Y is vertical, X is horizontal, and we're going to have it start horizontally. And then we'll do one more, X3, and then this is going to be equal to 8. And then our Y3 is going to be equal to 10. And I made a mistake here. This needs to be an equal sign, so we can edit it with the cursors and then hit enter to save. Perfect. And then we're also going to set up our snake length, so we can do snake SL for snake length, and it's going to start at 3. Awesome. Now, what we need to do is we need to add a direction for our snake so that our snake continues to move. And we'll start out, we're going to skip ahead a bit. We'll add more stuff later, but we're going to do 130, and then we're going to have dx is equal to 1. This is our direction X. And then dy is equal to 0. And this is going to allow us to move horizontally 1 pixel at a time and vertically 0 at this time. Perfect. So we set up some information for our snake game. Let's actually go ahead and start moving our body and displaying it. So we can actually display our body. We'll do 360, and then we'll leave a comment here, rem draw new head. This will be our snake head. And then we can actually use a poke command to poke it onto the screen. So we can do 370 poke, and then SM, which is our screen memory. We're going to add Y1, which in this case by default is 10. We set it up here on line 60. We set it to 10. So we're going to take our screen memory and add 10 to it. But then we also need to get 40 because it runs vertically. You're on a row. Each number is, uh, each row is 40 characters. So you would multiply this number by 40 to get that many rows. And then we're going to add on our horizontal. So we can do plus X, and then we'll pass in 1. And then because this is a poke command, this is our address, but then we need to poke in our character, what we're going to be doing. So we will do SN. Save that and run. And that puts us right there. We have now our snake spawning in to the game. He's right there, exactly where he needs to be. 10 rows down, 10 characters over. Perfect. Let's clear our screen and list out our program. Awesome. So now that we have our snake on the screen, let's go ahead and move our snake. So we'll add some other stuff in here. This is why we separated them out a little bit. We're going to do rem move body. This is going to be our move body section. And then we can do 230. And now we need to make a for loop. So for I is equal to our snake length, which in this case is 3, to 2. So we're actually counting backwards. And in order to count backwards, we need to pass in step -1, which lets us go backwards. So we're starting at 3, going to 2, or we're starting at whatever our snake length is, and we're going to 2. Then what we can do is we can set up our X. So we'll do XI, which is whatever number that is going to be equal to our XI minus 1. And essentially what we're doing is we're rewriting this data into our array. XI, whatever number we're on, is going to be equal to that number minus 1. It's going to allow our snake to actually move, essentially. Perfect. And actually keep track of all of the snakes. And then we need to keep track of our Y as well. So we'll do the same thing. YI is equal to YI minus 1. Perfect. And then we need to increase our I. So we'll do next I on 260. So now what we can do is we can move our head. We want to apply our DX or our DY to our X and our Y so that our snake can move. So to do this, we'll do 270 rem move head, just so we know that this is moving our head, and we'll do 280. Now to apply movement, this is very easy. We're going to take X1, which is our location on our very first one, which is our head, is just going to be X1, whatever that value is again, plus dx. We're adding our direction X to our X, and then we need to do the same for our Y. So Y1 equals Y 1, and then we're going to add our dy or direction Y to that. And then we want to create a loop so that this continues to loop over and over and over. We're going to add a lot more data in here. So we're going to skip to 460, and then we're just going to go to back to where we're kind of rerunning our code. So for right now, we're going to change this later, but we're going to go to 220 where we move our body. And now if we run this, we should have our snake, and it's moving on our direction X, and it's moving positive. So it's going to the right. Please make sure you end this program before it goes off the screen, or you will crash the game and have to start over, because once you go off the screen, you're going to start editing other addresses, which you do not want to do. That will cause some problems. So we're going to end this before we get too far. But now we have our snake, and he's able to grow, and he's able to move in one direction at the moment, but we're going to change that in a moment. So let's go ahead and list out our code again, and now we can start moving our snake. So to move our snake, that's actually pretty simple. We can do 400, and then we'll do rem check for key press. We're going to check if we press WASD, so we can do that and then move our snake accordingly. So to do this, we just need to do 410, and then we're going to get input, and we can just do get A since it's our first variable, and it's going to be a string. So we're going to get A, and then we can do 420. Now what we need to do is check our input to see if it matches a certain letter that we're looking for. In our case, WASD. So we can do if a $ is equal to A, then what do we want to do? Well, we just want to make it go left. So we can do that by doing dx, which is our direction x, is going to be equal to -1. And then our dy, because we only want it to move horizontally, is going to be equal to 0. Now we can do another one. We can do if a $ equals d. This means we're going to go to the right. Then we want our dx, our direction x, to be +1. And then we can do the same with our y. We want it to be 0. We don't want to move on the y. We only want to move on our x. So 440, we're going to check another one. This time we're going to check w because we want to go up. So then our dx is actually equal to 0 this time because we don't want to move horizontally, but we do want to move vertically and we want to go up. And because we want to go up, we want to go -1. And then we got one more, 450, if a $ is equal to S, then dx equals 0, and our dy is going to be +1. So now if we run our game, we can use WASD and we can move our snake around. Again, make sure you do not go off vertically or horizontally. You will edit the code and can cause issues. But we have the ability now to control our snake up, down, left, and right, which is awesome. So now we can exit out of that before we get off the screen. Let's clear it and list out our code. Here's what we've got so far. Now what we want to do is we want to be able to check for collisions. We want our game to end if we go off the screen. Two reasons. One, that's how you lose in the game. And two, we don't want to go off the screen. Otherwise, we're going to manipulate different lines of code in our system, which is going to cause problems. So we can do a collision check, and we can do 300 rem check wall collisions. Perfect. And then this is pretty simple. It's a little long if statement, but we can do if our x 1, again, this is where head is, where the first item in our array, which is our head. If our head is less than 0 on the x, or our head is greater than 39, which is the edge of the screen, or our y1, again, our head on the y, is less than 0, or our y1 is greater than 24, then we go to 900. 900 is going to be how we end our game. So this would throw an error because 900 doesn't exist. So let's go ahead and get a quick little 900 game over screen. So we'll do rem game over. And then we can do 910. We're going to clear the screen with print print CHR $147. That clears the screen. We're then going to just print, we'll add 2 spaces, game over. And then we want to add another space. So we can just do :print to print another blank line. And then we'll do 930, print score. And then we can do a semicolon to add to our print line, and we'll pass in our our snake length, SL, our snake length -3 because we started at 3. And then we can just make sure that we're ending our program, 940 end. So now if we run our game, we're going to be able to navigate around. But now if we go off the screen, it's going to end our game. It's going to say game over, score is 0. And I actually forgot to add a spaces for the score. So let's do that now. We'll list out 930 and insert 2 spaces there. So now we can go again. Our snake game is great. We haven't hit the corners yet because we're awesome. Oh, we messed up. Game over, 0. Now, obviously, if we run our game, this is not kind of what we want. We want to grow our snake as we collect food. So what we can do is we need to erase our tail so that we're not an endless snake creature. So let's list out our code and we can add to this. So we'll do 200 and then we'll do rem erase tail. And then we can do another poke command. So this poke command is very similar like the other one. We're going to do 210. We're going to poke screen memory with our Y. And then this time our snake length. How many snakes do we have? By default, we have 3. If we get more, it'll be 4, 5, 6, etc. So we want to make sure that we get the last one. And then we're going to multiply that by 40 because, again, we're trying to figure out where that is horizontally on our screen. And then we're going to add our X snake length. And then this one is our SP. This is the space that we use to make sure that we're deleting anything that's in that section. Now, this is not going to work by default because, like I said earlier, we have to change our go-to. So if we switch our go-to from if we list 460, our go-to was 220, which was taking us where we move our body. Now we want to make sure that we go to where we erase our tail. So we're going to move, erase our tail, continue on, etc. So we're going to switch this 460, go to 200, which we just wrote. And now when we run our game, we should see that we only have by default 2. And that's because it's always erasing the third one. And then when we add more, that's fine. So we're going to start out a little small. We can maybe make this 4. In fact, we can let it end. And then if we list out 90 where we have our snake length, we could switch this number from 3 to 4. And then if we run our game, we would actually have 3 things of our snake going around. But we'll start with 2. We're a little baby snake. So we can list back our code and that's 90 again. And then let's switch that back to 3 for now. And then we can list out all of our code. All right, so now we have our snake being able to move around. His tail is erasing, so he's not an endless snake monster. And now what we can do is we can make it where he can actually eat to grow. So let's add in some food. Let's spawn in some food for our snake to be able to eat. We're going to put this at 100 and we can do rem place food. And then let's go ahead and generate at 110. We're going to create a random X and a random Y for our food to spawn in at. And that's very simple. We can do fx for food X is going to be equal to integer whole number. We're going to then do our random number, and we're going to get a random number from 0 to 1. And then we need to multiply that by the amount of columns, which in this case is 40. That is going to be our random X. And then the same for our random Y. We'll do a colon FY is equal to int. We'll do random between 0 and 1. We need to then take that, multiply it by 25, and then end it. And then make sure you hit enter. Now that we have a random X and a random Y, we can go ahead and poke that onto the screen. And we do this by same way we did our snake. So poke SM, which is our screen memory. This time we're going to take our foods Y. We're going to multiply that by 40. So we know exactly where it is supposed to be horizontally. And then we're going to add our food X. And what character are we going to use? We already have a built-in character that we saved earlier. We're going to do FD for food. So that's going to take the food character that we specified and we're going to poke it at the screen memory. We're going to add our foods Y times 40 and then add our foods X. And now if we run this, hey, we got a little food up here. Now, this is actually going to, quote, eat it. We don't actually have any logic of eating it, but when our snake goes over that section and then leaves, it's replaced with our blank tile, say, or blank character. So that's why it actually disappears and looks like we eat it. So if we run that again, it randomly spawns to a different location and we can run over it and quote, eat it, but we can't eat it yet. So let's go ahead and actually do something when we eat our food. So we can list out the code. We don't really need to, but let's go ahead and do that. So what we can do now is we want to check if we collide with the food. So to do this, we can do 380 rem check for food collision. And then what do we want to do? Well, it's very simple. We just need to check if our x, which is our head, x1, which is our head, is equal to our food x. And we want to check if our y1, the y of our head, is equal to food y, fy, right? Fy, food y, trying to explain what these letters mean. And then if it is, then we just want to go sub. It's a little bit different. We're going to go sub 600. Go sub 600 allows us to go to a subroutine, which means if this happens, we're going to go somewhere else in the code. We're going to run that code, and then we're going to come back to this section and continue on with the rest of our code. So what do we want to do at 600? Well, what we want to do is we want to do what we normally do. When we eat food as a snake, we're going to grow. So we'll do rem grow snake. And growing the snake is actually pretty simple. First, what we need to do is we need to take our snake length, SL. We're going to take it again, and we're just going to add 1 to it. We're going to increase our snake length by 1. Then what we need to do is we need to change our array so that we physically add it. We've increased the length of our snake. Now we need to increase the length of our array. So we can do that by doing 620 x SL, which is our snake length, is going to be equal to SL minus 1, just like we did before. And then again, with our we want the y, with our y, snake length is equal to y, snake length minus 1. This allows us to add to our array, so that way we actually have a list of our snake pieces or body parts in the array, and that's how we do that. Now that we've grown our snake, what we want to do then is place another food randomly. So we can do 640 rem place new food. And then this is quite simple. We're just going to do what we did before. We're going to get a random fx, a food x. It's going to be int random 1 times 40. Oops, times 40. There we go. And then we're going to get our food y, and we're going to make that random as well. Int random 1 times 40. Oh, times 25, because we're on the rows. So we're going to get a random x between 0 and 40, and we're going to get a random x between 0 and 25. So that way we know where to go. Then what we need to do is poke that back onto the screen. We've already done this before. That's one thing I like about this program. You do a lot of the same thing over and over, kind of muscle memory. We're going to randomize stuff if we want to. We're going to poke it into the system. And then here we're going to get our, again, our foods y multiplied by 40, add our food x to that, and then be the character food, which is awesome. And now this time, because we did a go sub, we need to make sure we tell the program to return back to where it left off. In 390, it went here, we've run the code, we need to come back to 390 and continue on. In this case, it would go to 400, etc. So we'll do 670 return. Always make sure you return. And now if we run our game, we can actually collect our food, and we should grow. And it should randomly spawn at a different location, which it did. Perfect. And then if we go here again, fantastic. So there we go. We now checked collisions on our food, and then we can actually grow. The last thing we want to do right now is we want to make it where if we collide with ourselves, our program ends, right? Because as you can see there, if we do that, it kind of glitches out on the design. It looks a little weird. And also, if you're used to Snake, your character will if it hits itself, it ends. So let's go ahead and end that. We can clear the screen. We got a score of 6. Awesome. But now what we can do is we can just check to see if we've collided with ourselves, then we also end the game as well. And to do this, we can do 320 rem check self collision, and then 330, we're going to do a loop. So we're going to check if for I is equal to 2, which is anything but our body, to the length of our snake, whatever that length is. We're going to loop through every piece of our snake to see if we'd hit ourselves. Then what we want to do is we want to check if our head, x1, is equal to x I, which is whatever body part that we've come across, and our y1, our head, is equal to any body part on our y. So y1 is equal to yi, x1 is equal to xi. Then we're going to go to the end of our game, which is 900. And then 350, we need to increase I every time we check through it. Now, if we run our game, we can get some food. We can't hit ourselves now. We're too small, right? But we're going to get some food and we're going to grow. If we can get the food. Oh, I messed up. Let's try again. You can make a game, but can you be good at it? That's the question. So we're going to get some food here. We're at 3. We're at 4. Let's get one more food. And now we should be able to hit ourselves. Yep, we were able to run into a loop and hit ourselves. All right, so now our game kind of works. We have a loop for the game. We'll run the code. Well, what we can do now is just add a little bit more flair to it. We're going to change up some of the colors so that way we have a white snake and yellow food to match the thumbnail that I chose. And then we're also going to change some of the borders. So what we can do is we can go through and start editing some of the code we've already written and add a few more lines. So we're going to list 10. List 10 was our print at the very beginning. We're going to change this to also poke some colors so that we can change our background and our border. So we're going to poke 53280. This is our border, and we're going to make it a dark gray, which is 11. And then we're going to also poke 53281. This is our background, and we're going to make it 0. And then if we run that, we now have a dark gray border with a black background. So anytime we change colors, as you can see, we're editing code, but we're back at weird colors. So I always like to change my colors back. So if we list out our end area, 900 to 940, we're going to see where our code is. We didn't really leave much space, so we can just do 935. This is going to be right before we end. We just want to poke our colors back to what they were by default. Again, I don't even know if this is good practice, but I feel like it should be. Always change your colors back to the defaults. That way you're not changing, if someone ends your game, you're not changing their program. So now if we run our game and then we lose, it should give us our game over and switch everything back to the regular colors. So now what we want to do is we want to add some colors for our food. So we can do that very easily. Here is we can list out where our food is. So our food is 100 to 125, actually 1 to 120. So right here, we can do right after 120, we'll write this in here. We're just going to do another poke command to change the color of our character. This is done the same way we poke the character in the first place, but instead of using the screen memory, we're going to use our address color memory. So we'll do CM plus, and by now you should be an expert at this. I won't even say it out loud and see if you know what you're doing. Just kidding. This is a tutorial. But we have our Y times 40 plus our X. And then we're going to just pass in our food color this time, FC. And then if we run this, we can now see our food is now yellow rather than the blue that it was before. Now if we were to collect this, let's go ahead and collect. Oops. Also, you can't run into yourself backwards. Otherwise, you will end the game. So make sure. Now, if you collect this, few things are happening here. One, we are getting colored because we aren't changing the color. All right, so next what we need to do is we need to change the color of our snake so that it doesn't change colors when we try to eat the food. And we can do this by finding out where we change our color or where we add our snake to begin with. So we can list out 360 and then we'll list out to 380. Perfect. So here's where we're drawing our new head. All we need to do is poke a color of our snake right after we draw it. So we'll do 375, poke. We're going to do our color memory. We're going to add our Y, which is 1, which is our head. And then we're going to multiply that by 40, like we normally do. And then we're going to add in our X1, which is our head's X. And then instead of passing in our snake, we're going to pass in our snake color SC. Now, when we run our game, our snake is going to be white. And when he eats something, like this food over here, our snake stays white. Now, we ran into two issues here. One, we want to make sure that our food stays the color yellow. And the reason why is because once we eat it, we make another one and we're not changing that color of the one we generate. So we can actually go ahead and end the game. And then let's figure out where we write that code. So we can list out 640 and then we'll do to 670. This is where we place a new food, and we can do that by typing in 665, and we're going to poke our color memory just like before with our food Y times 40, and then we're going to add our food X just like up there. And then instead of passing in the food character, we're going to pass in our food color. And then we can hit run. And now when we eat the food, they should always spawn in as yellow as it does. And then the last code that we need to add in is when we erase our tail, we can just make sure that we switch the colors back to the default colors. So if we list 200 to 220, this is where we draw our tail. And erase our tail, I should say. We can do 215 poke, CM plus Y SL times 40 plus XSL. So essentially, and then we're going to pass in our space color. Actually, we're going to pass in 0 because we want it to be black. And essentially all we're doing is we're poking in our color memory, the same location that we would clear our tail. We're going to set it to black so it's still the same background color. And then if we run our game, we should pretty much have our game all set. Now, if you've been following along with this tutorial, you've kind of seen some things that I've tried to hide a little bit, but I'm going to show you here now that we have our game completely done. As you can see, our game slows down. And the reason why our game slows down, if you saw at the beginning, when we first had our snake running, our game was super fast. The snakes were running. We had many, many snakes on the screen. And that's because we weren't doing a few things. We weren't checking for collisions with ourselves. And those are expensive in terms of processing powers. And as we grow more and more, we get more and more snake lengths and we're checking it. So there's definitely ways that you can improve this code and make it a little bit faster. But I wanted to make the snake game in basic because one, this isn't really a good game to make in basic for those exact reasons. But it does give you the understanding of how to make a game in basic, kind of get your feet wet, to make that. Basic games are going to be much suited for not a lot of checks or stuff like that. And I have a few other games that I'm going to be making in basic that will actually hopefully should run much better. But as you can see, Snake is not going to be one of those games. But I wanted to still make this video because we're going to take this Snake example game in the future and then we're going to actually code it using assembly so we actually get a good snake game. It's still simple, but a good snake game that will will still run relatively fine. And that way we can compare the difference between how a game would run in BASIC compared to how a game would run in assembly, which is direct machine code eventually. It's going to run much faster. But even though BASIC is slow, you should still use BASIC to prototype your game and get an idea of what you're trying to do before you dive into coding that same game in assembly. This way, you have a good understanding of exactly what you're trying to accomplish, and then you just need to figure out how to write that in the assembly code. But as you can see, we are chugging along. This game started a little fast, but now it's very easy to collect all the food. But I still think it's kind of funny. Our snake just ate too much, and now he is very hard to move, which, just like all of us, if we eat too much, it's very hard for us to move. So I do find that part kind of funny. But yeah, this is your very first, well, maybe your first, at least first on my channel, making a basic game. And I hope you enjoyed it. If you have any questions, let me know in the comments below. And we'll wait till we get to the end of the screen, make sure everything ends properly, and we'll see what our final score is. I do kind of want to eat one more, but that's going to take longer. So we'll wait till the end and finish it. You could also improve upon this by adding an intro screen or an outro screen when you lose. Definitely things we'll do in the future, but I hope you enjoyed this video. Let me know what you'd like to see next, and I'll see you in the next one.